So we have the integral of secant squared x divided by tangent to the fourth x with respect to x. The first thing your brain should do is recognize that as foreign. It's alien. We have never done anything like it before. Now the good news is the angle's just x, and we don't have an angle sacrifice to make. The bad news is that is not one of the original 6. Do you guys see that? Mm-hmm. It's not one of those 6 we talked about in the beginning. If it's not one of the original 6, it is not a trig problem. I know it looks like a trig problem to you, but it is not a trig problem. So I'm going to say it one more time. If it is not one of the original 6, it is not a trig problem. It's a powerful problem. Much the way the derivative we talked about over here, one of those was not a trig problem. One of them was more of a power rule problem. Kind of makes sense? Okay. So the first thing we're going to do is we're going to look at this differently. We're going to look at it as secant squared of x tangent to the negative 4 of x. So we're going to bring that tangent up to the top. And I'm going to put them in parentheses so that you can stop thinking of them as trig functions and start seeing them as parentheses to a power. So this guy I'm going to write as secant of x quantity squared, because we talked about how that really means the same thing. And this guy I'm going to write as tangent of x quantity to the what?
To the
negative 4. Okay. So now instead of seeing trig problems, what I see are parentheses to a power. And any time you want to integrate parentheses to a power, you have to sacrifice the derivative of the inside of that parentheses. So one of these is going to be our u, and the other one's going to be given away as the derivative of that. So usually it's the more complicated angle. The more complicated exponent is going to stay, and the less complicated is going to go. So if I imagine that this is my u, what's the derivative of it?
Secant squared.
Secant squared of x, right? Which is what I have. So I think of this as u, and these two guys together comprise the derivative of the inside of that parentheses. It has nothing to do with trig. It's just like all the ones we did before. If you give away the derivative of the inside of a parenthesis, you can do the power rule to it. So we're going to rearrange this, and we're going to see it as tangent of x all to the 4th power. But this guy, instead of seeing as a parentheses to the power, we want to now envision him again as just plain secant squared. So the way I've written it now, negative 4, thank you. So the way we've written it now, we can see parentheses to a power, and this is the derivative of the inside, right? So if we give this away in some strange form, that will allow us the right to just add 1 to the power and divide by the new power. So it's not a trig problem. It has nothing to do with reversing a trig derivative. It's literally just a parentheses to a power. So we're going to add 1 to the power, and that will become negative 3, and divide by the new power. So divide by negative 3, and put our plus c on there. And then at the end, we do want to rearrange it. We're going to write it back as the tangent on the bottom to the positive 3 power. So we have negative 1 over 3, tangent to the positive 3. And if you want to leave it in parentheses, that's fine. But a lot of people at the end will put the exponent back here. This kind of depends on how your brain sees it. What do you guys think?
I love it.
It's not bad. It's really not bad.
I feel like if we say it's not bad, we're going to go to the next problem.
Well, it gets easier. But what you have to realize, you have to realize that it's training your brain to see it a certain way. So when you approach it, the very first thing you need to do is decide, is it really a trig problem or is it a power rule problem? And the way you tell is if it's not one of these original 6, right here, if it's not one of these 6, regardless of the angle, like if it doesn't match exactly one of these 6, including the squares where necessary, it's not a trig problem. It just looks like a trig problem. So we'll look at a new one, and I'll let you kind of start on it and see how far you can get. We have the integral of cosine. I didn't intend for it to. I wanted it there. so that we went all the way back. So we have the integral of cosine of x times the square root of 2 minus sine x with respect to x. So what's the first thing you're going to do?
Change that to a parentheses.
Change that to a parentheses to the 1/2 power. And then see if you can figure it out from there.
I would think.
Okay, so what we're going to do first is what we talked about. We are going to rewrite this as 2 minus sine x to the positive 1/2 power. And then we are going to put this cosine x over here because we are hoping, since it can't be distributed, we're hoping that that's going to be used as part of our sacrifice to reverse the chain rule, right? Okay, so what we have is a parentheses to a power, and we need to give away the derivative of the inside. So what is the derivative of 2 minus sine x?
Cosine x.
Positive or negative?
Negative.
Negative. Yeah. The derivative of plain sine is plain cosine, but negative sine is negative cosine. So the only thing missing is a negative. And if I give all of this away, it will allow me to treat this not like a trig problem, but like a power rule problem. So if I make up a negative one inside, I also need to balance it outside with a negative. Okay, so we keep the negative, add 1 to the power, and that brings us up to what power?
3/2.
3/2, and divide by 3/2 is the same as multiplying by
2/3.
2/3 plus c, and if you want to change it back to radical form, you may, but I personally think at this point it's easier just to leave it like that.
Agreed.
So they're not too bad. Let's see if we can get one more before we break. This one is the integral of x squared cosecant squared of x cubed. So I'll give you a minute to decide, is this a trig problem or is it not a trig problem?
Oh.
Okay, so trig problem or not a trig problem?
Trig.
It's a trig problem. It's not a power rule problem. We know that because if you look at the only trig function we have, it is a cosecant what? Squared. And that is one of the original 6. So the question becomes, what's up with that x squared? So if I have cosecant squared of x cubed, if I didn't have the x squared, would I be allowed to integrate that back to negative cotangent?
No, because you need 3x squared.
You have to sacrifice the derivative of the angle. And that's true for any time you're dealing with trig. Like you have to have the derivative of the angle there. And so the derivative of the angle would be 3x squared. So coincidentally, I already have the variable portion of that, right?
Mm-hmm.
So if I can make up a 3, and it turns out I can do that, and balance it with a 1/3, then this right here will allow me to ignore the angle and integrate that, not as if it's a power, but as if it's just one of those 6 basic trig functions. I can treat it just like a cosecant squared of x. I can reverse it to 1/3, and then the cosecant squared will integrate back to negative cotangent, and you just keep the angle as is. You don't have to do anything else to the angle. You will never apply the power rule to the angle. You'll never add 1 to the angle power. So I know that one's a little confusing. We'll probably look at a couple more similar to that.